So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 171 and in this video we talking about a special keyword, and this keyword is this. It's a keyword, but it is special because this keyword is used as a pointer, which means, let me show you, demonstrate what this means. We learned in my last video how we create pointers here, right? And a pointer, you need a class or something like, let's say, int, and then you make something like an asterisk here, because that is the way how we declare pointers, and then you choose a variable name, for example, pointer to int. And then we learned we could make something, assign it, or just write at start null there, because pointer we don't have to assign at the declaration immediately an address, but later when we want to use the pointer, we learned we have to assign an address. So let's create an int here as well. Int my telephone number, like I created all-time telephone number. And I say this is this value, and let's assign this one here as well. And I say, okay, we need the address operator. We learned this, a pointer. Its value is all time the address. Don't mix it with the pointed value. This is the pointer value, address, and the pointed value is this one here, which we use with the difference operator, which was this one here, pointer to int. And here now when I use it this way, I am using the pointed value, which is I point to this one, and when I point to this one, the value of this one is this one. And with this one I can change it. For example, in this case I set it to 5. So that was a fast repetition of a very basic pointer, how we use it. And now we are going to back to this keyword, new keyword, which is a this, and the this pointer means this word here, this, is used as a pointer. What I mean with that, let's make it fast example. We create a variable, and actually that's the case here. Before I go there and create it, this pointer this is not created by us. This pointer will be created by the compiler, and that's a big difference. But we have just to know it, that the compiler is creating this. But what does the compiler do is something similar, not absolute accurate like that what I do, but similar like this. It's first of all, you must be in a class. So outside of a class, it will not work. But I will explain why in a moment. But what it is doing is actually this one. Again, we need a class. For example, I have here a example class. This example I took just from this site here, which we are going to cover in a moment. This is here this class T here, and then here are some examples which I will discuss here in a moment. So first of all, this like I said, this pointer this will be created only in a class because it's a special pointer, and that's why it's a special keyword, this. Because if it's not a special pointer, we could make something like that, what I did. I could just randomly create a normal pointer to this class. Here I create first a normal pointer to this class T. I would make this something like so, T pointer my normal pointer. And then I could assign again a value for it, but here I need the class T, I don't have one, so let's use just a null pointer. So like I said, we can assign at start nothing. So with that said, what is now the this pointer? The this pointer is exactly something like that. Now T, we start again with the class, and that's very important where it is created. So when you are using this class T here, when I create a variable, which means let's create a variable for T first, then let's do this one. So T variable, for example, I don't know what we do here. Demonstration of this. Let's call this demonstration of this. All right, for the example. Demonstration of this is okay. And yeah, I need, when I create this this class here, we learned all time watch the constructor, and here I changed a little bit the example. The original example has only this little constructor. I made it a little bit more complicated so that we can get more confused. No, that was a bad joke. We will get not more confused. It makes it more clear what I want to demonstrate you later. But we watched the constructor. We learned what a constructor is. It has the same class name like the constructor name, so T and T, we can see this is the constructor. We have no default constructor, and we have here two parameters, and we have here an initializer with two lines, which means we initialize first X and Y, and in a moment more. So let's see, I have to use it, or I can use it, so I use here X and Y. Let's give it a number 57, for example, 57, and with that I created a variable and I initialized the values here. At least I used the constructor here, and then we have to check what the constructor does, but later more. So here I just created this variable demonstration of this. We have this, and this is just the class here, which is the type here. So how now I said when we create at this point a variable here, this one. So, and all time when you create any other variable as well for this class T, then the compiler will create this, where is it? Then the compiler will create a pointer which is called this, all right? So that the compiler will do, but to show you what the compiler will do behind the scene, and we can't see it, that's why we have here in this class no this declaration, because the compiler make this all behind the scene. And what he does is that this pointer is created here behind the scene like this one, T, this, and I don't know if I write here null ptr. I don't know exactly how the compiler is doing this, but we are not allowed to this because this is a keyword. That's why it's not allowed here. But you can see normally it would be a normal variable we are allowed to do. This pointer we are not allowed to do because it's a special pointer which we have to use, which is created in a class. So that's the first very important thing. It is created in a class, and this creation process, or let's say the declaration process, is not shown. What do I mean with not shown? Let's examine this class here a little bit, this demonstration class here, demonstration of this. So we have here, I create a variable name with these values here of this class. But like I said, every class is creating this pointer. So not only this class here, for every class. And we learned also struct and union are similar to classes. They create also something like a this pointer. So this special word this. But when we watch this class here, I have set here public. We see here variable declaration, then non-static function members, and here again a non-static member, function member with const, and here we have again a non-static member function. But where is the declaration which I showed you here, which is not allowed here? But where is that here? And like I said, this is not shown, which means we don't see it as a programmer because the compiler is creating this behind the scene. And creating behind the scene is called this word which I mentioned one time with implicit creation. The compiler, implicit means all time the compiler is doing something behind the scene. Explicit means most time we are doing it intentionally something. So, and we are using this one here. So first of all, we learned now, okay, that this operator is created by the compiler and in a class. That's very important, not outside of a class. So, and the next step is, okay, when the, let me write this perhaps again, this pointer, this one here is created, null ptr is created. Of course, this one works not here because, like I said, it's a keyword, and this one is probably also not there because the compiler has optimization and so. But in what we have later is something like this one. This one is creating the compiler behind the scene and with optimization on all kinds of stuff. But what is important now? This one we are not seeing, okay, but we have to check out what this means. So what I mean with that, so we learned a pointer points, first of all, this here is a pointer, and the value of a this is an address, right? So when the compiler creates here behind the scene exactly that what I show you here, what is the address of this here? And the address of this here is actually, because we are defining the type where it is created in the class T. All right, this is this type here. It is a pointer, and the address is actually again T. So it is pointing there where it is created. So what does this mean? So I created here, for example, this pointer, and then I get a reference to myself, and then I save it here in this T more or less. So, and this kind of explanation sounds a little bit not easy to follow, but I will make in the next video some more reference examples with this. And then we will understand this kind of stuff more. What you have to know is just that this variable is here created, and it is all time referring to this class where it is created. So this pointer, this here is pointing to this T, which means we have access to all the things here because I'm pointing to this address, and now I can access here that what the pointer is allowed to access. All right, I hope this is so far clear. Then we go to this pointer here. We have talked a little bit about this, and here you can pause here shortly the video and read here, oops, what it says here. Don't worry if you understand not all kind of stuff, because I will explain this again with demonstrations here. But of course, you have to read this again online or in a C++ book again, a little bit more for details, a little bit more for accurate explanations and so, because in this video I make again just the use case, which is important for practical programming. And the details again would take too much time. That's why all time use a good C++ book, a good online research resource where all is explained. So I hope you read this little thing here, because we make now go jump here to this one, and I explain this explanation here, and I will refer to this one here. Just for a fast recap, they say here are the use cases where you are allowed to use, and here on top is just what the this is, right? It is an expression and then it is implicit here, the implicit object operator. This one is a little bit complicated. Let's say not really complicated, but when you read the details, then it's not so obvious, because a lot of stuff the compiler do behind the scene. That's why you have to read here a little bit more, where it's better explained. And you can of course go into the site where this implicit object parameters, read here and try to understand this as well. And all time when you hear the word implicit, like here, it means it is created behind the scene. And who is creating behind the scene? Yes, it is the compiler. Compiler is doing something, and so on. So we jump here to these examples, and I will refer here to these things here when we start. So let's get started. First of all, we have here a class author. All right, that's easy, a class. And then we have here a member variable, here again a member variable with an initializer, here a member function, non-static member function, and here again a variable just a declaration. And then we have, or the variable is all-time declaration, the definition at the same time, we know this, but when I say declaration, I mean all time without an initializer normally. And that's bad, by the way, but yeah. And then we have here, and that's very important here, it says struct. Careful, when you hear struct and class, it's almost the same. I said this all time. And the only difference is it's almost the same. It's not the same. The difference is struct has different access specifier, which means by default access specifier is here public, and here what you all see here on top is all private, which means we could not access this from outside, but that we know already. So we dive into the examples now and try to read this and try to understand this. Then you can skip all that what I explain here in a moment. So first of all, we start with a class auto here. This is the first place, not the examples here, the class auto. And what I said before, when we create a, let me show you this, when we create a variable, here I'm creating a variable for a class. So when I create here a variable for this auto, then the the compiler is creating, declaring a hidden this pointer. And it's using this pointer here in the class where we created. And it is important that you have to read perhaps this line as well. Important is here at this line that you see with the innermost enclosing class of its appearance, which means this pointer which you are creating is all time associated now with the innermost enclosing class, which means if you have here another class, and we have here another class, and I said class, struct, and unions, they behave similar and they are treated similar, and you can see they are saying just innermost enclosing class, even if it's called a struct here, class, struct, similar, and that counts for both. And they mean here all time when you create a class, or here also struct or a union, then the compiler will create also a new this for this operator. So which means I have here a class outer, I have here a called struct inner, you can call it if you want also class inner, but important is all time when you create a class struct, the compiler is creating behind the scene a this special for this struct here or this class here. So all time it is creating a new this. So careful, which means this here, what you see here, and this here is not the same this. They are absolute different this, because this one is a pointer who is pointing to this inner. This one is created here in this class here. This here is pointing to this one here. So that's very important to note. And now we can start with these examples. And I hope you read here a little bit, because I will just refer to this one and explain here this example. So first of all, what we have here, it says here we create a variable, we create here a variable name, which is a, and then we have an array, we'll know this. And the numbers of the array is realized with this size of operator, which is just giving us a number in bytes most time. And we are using here the this, and we are using the this here as a difference operator, which means this is the pointer, and with an asterisk in front, it means we are differencing the this. So, and then we are assigning that here as the value of this array. So, but let's read here the arrow, why it says this is an arrow. And here's also the explanation. Not inside a member function, because here is one rule. This pointer, the special pointer, can only used in these categories here, and it must be in a member function. And they say all time non-static. And the reason in this word non-static, you will see, you will hear, read, and see in many places. And what it does mean non-static, we have a normal function without the word static. And of course, it's a member of a class, because member function means all time member towards anything. In this case, towards the class. And yeah, I just noted this because you will see this word non-static almost added in every place, because there is also the static versions, and the static version behaves different a little bit, and that's why they all time highlight this one with non-static and static. Just a side note. All right, let's go back here to this one. We was talking why we were talking why this one here is an error, right? And yeah, it says here not inside a member function, and member function, it must be in a member function or one of these other things what we have here. We have not talked about everything here. Lambda expression we don't know. This one we don't know. At least we have not talked in this tutorial, not in this tutorial. So we have only talked about this default member initializer, non-static member functions, and declarations. So we will only care about these cases. The other ones we skip. All right. Okay. So we figured out no member function. Yes, indeed, it's not a member function. This one is a member, but not a member function. It is just a member variable. All right. That's the case. It's okay. Let's go to the next size. No, not size. To the next line. And here we see it's okay, and it says in default member initializer. You can see this one is also just a variable here, like this one, but this one got a initializer, and it says it is in a default member initializer because this one is a member variable like this one, but here the difference is that we are using it here in a member initializer. Actually not. Actually, the member initializer is here at this point. So it counts for the size of, right? So this one is counting for the size of. And this one here in it, it's the member initializer. Careful, that can irritate a little bit. So the member initializer is here, and that's why it counts. All right. And yeah, we have here with default member initializer, and when I click this one, you can see something like that. All right, default member initializer, we initialize it. That's why. All right, let's go to the next one. And here we have a non-static member function, which is called void f, and it goes from here to here. And the first one, it says, okay, interesting is here when you read this line and this line, they are exactly the same. The only difference is this is called variable a and this is called variable b. But here it was an arrow, but now it says, okay, what is the difference? The difference is just here we have a member function, and here we have not a member function. And here, this one is called in the member function body. And here, of course, we have no body because it's not a member function. And that's why we have an OK, because it says non-static member functions it's allowed to call. All right, that's also good. That's nice. So you can see in many function places are allowed, not in all, but in many. And here, the next thing, now we come to this nested class. And here, remember about this line here, perhaps again, what happens now is we are creating a new class or struct. And when we create all time a new class or struct, sorry, then this operator is create the compiler will create a new this operator for this class. So not the same here. They have here a this operator for this one, and we have a this operator for this one, because it must distinguish these operators here. I mean, the members here. So we have here a separate this operator. So this one is not the same like this one. It looks on the same. But important is now, why is this an error? We have an error here. So, and when we read this line here, it makes sense. But when we read this line here, we can get a little bit confused because we have here a member function. But important is innermost enclosing class, which means we have here a member function which is a member. This void f is a member of class author. And like I said, when we create a class, the compiler is creating a this, and the first this is pointing to this one. And if it's pointing to this one, it can see this member function. And that's why this one is considered as a member function. And when we call it, it says here, okay. But here, on this case, we create a new class or struct. Then the compiler is creating here at this point a new this pointer for this here. And it's in this body now, this pointer, and this pointer sees only this one here, this new pointer. It sees only a member variable, which is not a function, and that's why we have an error. All right, I hope this makes a little bit sense so far. That was this explanation. And let's go here a little bit more. Here it says only what the type of the pointer is. And like I said before at this line, the type of a pointer is where the pointer is created and points to. So first of all, where it is created, for example, when we have author, here the compiler will create behind the scene a pointer to author, and it points to this one. That's why it's the type author T here, and here it will create to inner. But how it is made, let me show you an example here. Here is it. Here. No, this one. Oh, yes, it is right. T, is this T here? No, it's not. This was another example. Okay, let's make another example. Here, this, not this other example, let's make this example. So when I create a, the type of author would be here just author pointer this. This is the first, right? Because this is the pointer and this is our type here. This is the type here, author. When I created, when the compiler created in this class, for this class, not in this class, for this class, I must say. And when I create, when the compiler created this for this other struct here, then it is inner type, for example, and inner type. All right. This, but you see the same word this and this. The only difference is here author, and because it's a special pointer, this same word is here allowed because it is, I don't know how it is made behind the scene in the compiler and compiled and optimized and whatever. That's more a technical term. That's more for advanced people if you want to understand this kind of stuff. This kind of stuff we skip at starter, but of course if you want to go later more advanced and read the good textbooks and C++ good books for advanced things, how all works behind the scene, then you can see why this is possible with the same name and so. But right now we skip this because we won't try just to understand what this is. So the type is this one, and I will show you later that indeed the type is this. So I talked a lot, and all the stuff here I will talk in the next video, I think, because I want to go from here. And this one we skip, and this one we skip, but this here, these are the examples which I want to show you step by step again. And that takes again a lot of time. That's why I show you one more thing, this type here, and how the compiler is creating actually a this. And we will talk a little bit more in the next video. First of all, I have to delete this one. And here I create a normal variable pointer. We can keep this, but we are interested in this line here. This line here, let's keep not this. Let's kick, at least let's cut this out and put this. Perhaps I need this. Let me put this one here and comment this out. I don't know if I need this, but right now I'm interested only creating a variable. I create here this variable demonstration of this. All right, I use the constructor, which is this. All right, and now how I can see that, where is the this, how I can see that. And I said, no, we don't see the creation of this, but with debug we can see it a little bit. How it is not in detail, but in debug mode a little bit. So what we do is, when you create this variable for your class, and I use this demonstration class here T, and you point here this debug symbol, and then you start here the game, when you start here the program, then what happens is we go step by step and see what happens here in this output below. At the start, you can see the cursor is here at the start, so it is not evaluating this line here. Only a little bit actually, it is evaluating some parts of it. And we can see the, first of all, the compiler sees here a type T, which is that what I'm creating, this T here. All right, we can see it here, T, and it sees also the name here, this demonstration of this, we can see it here. But here was this little arrow when I opened it up. Then we have here two values, which is x and y, this is this x here and this y, these are not assigned right now. This I have give here, so the compiler sees actually only the declaration without the initialization of this variable. So it's only seeing it without this value 5, 7 here. This 5, 7 will be visible in a moment when I press, but important, at this point we see no this. You see a this here? No. You see here this here? No. Because we are right now not in a class. We will jump now in a class when I go to the next line, because I will jump to the constructor. This is a constructor and the constructor is here. And look what happens now. I jump in a constructor and here we are at this point. My cursor blinks here at this line. And when we go down and open up this one, we see now a this. This is exactly a pointer. This is the name this, what I showed you here. This here, this is created here. And the value, I mean, not the value, the type is here. When I go right, you can see it points to the type where it is created. And it was created here for this one. T is created here, and the type, the pointer is now pointing to T. And when you want to understand this one more in detail, like I said, you have to read here a book, Good C++ Explanation, and again a little bit what the compiler is doing. Not so easy for beginners, I would say, and starters, but if you are interested, why not? If not, also okay, because we are starters, we learn just the use cases here first. But here you see also a little bit what happens. So here the this is created, and I think what happens next I will explain in the next video. By the way, just so that you can understand the other values here too, you can see this line here and this line here was my first call. That was this line here actually. X was 5, you can see it's 5, it's an int, and 7 is this line here, was my y, and here the this pointer points to this class, and we have here also a x and y. What is this x and y? The x here is this one here actually, and this y here is where's the y? Why they put the y here like all time? I copied it from the example. That's why I have to search this. All time bad when you have to search something like that. But here is the y. All right. And we can see that this is accessing them. And we will talk about this a little bit more in the next video, because it here in the next line, it explains what it means accessing them. And I will make then also these examples here to demonstrate what it means accessing them. Okay, that was a little introduction to the this pointer. And of course, you should read this online or in a good C++ book more in detail, a little bit better explained perhaps, because I'm concentrating here only on the practical use, which means the theoretical correctness is not so important, because I trust the theoretical guys that they made all fine nice. We learn how to use it in the practical use cases, right? So with that said, if you have any question, any complaints like all time, write it in the comments below. And in the next video, we will continue with this one and these examples, and see you in the next. And like all time, never give up and have fun.